In this video, we want to discover a new shape. To do that, we're actually going to start back here on the cone from the first video. Now, let's say instead of this being a cone, I say, actually, JK, I wanted it to be a cylinder by rotating a rectangle, which is what we learned in the last video. If we rotate a rectangle, it's a cylinder. Rotate a triangle, it's a cone. So I add my skinny oval to make it look like a cylinder. And you'll notice that this cone fits inside the cylinder. So what we're really saying is this cone is only a fraction of the entire cylinder. That's why the equation for a cylinder is pi r squared h, and for a cone it's 1/3 pi r squared h, because a cone is a fraction of a cylinder. So that's where those equations come from. This cone is 1/3 of this whole cylinder shape. So the question we want to then ask is, what about the rest of the shape? What if instead of the green part, I wanted to find this pink part? And this is why you can see some people call this shape the anti-cone, because it's the cylinder except for the cone. The whole cylinder minus the cone. We want the whole cylinder, but take the cone out. Some people also call this shape the stadium, because you can kind of imagine that we have like little seats right here. And then it kind of looks like a stadium with stadium seating down the middle. Regardless, for this class, I'm going to call this shape the stadium because I like that name. I feel like anti-cone sounds all menacing. So I'm going to call it the stadium. But we need to find an equation for the volume of this figure. So I want to find what is the volume of this pink shape. So let's think about this. I know the volume of the whole cylinder is pi r squared h. I also know the volume of the cone is a fraction of that cylinder, a piece of that cylinder. It's 1/3 pi r squared h. So now we want to find the volume of this stadium. So if this whole thing is pi r squared h, the cone is 1/3 pi r squared h. If I take the cone out so that I'm only left with the pink stuff, I essentially want the the cylinder minus the cone. So if I want the whole cylinder, but I want to take out 1/3 of it, then I'm going to be left with 2/3 of it. Think of it like a pie. I have the whole pie. I want to take out 1/3 of the pie. So I'm left with 2/3 of the pie. So the volume of a stadium is this equation right here, 2/3 pi r squared h. That's the stadium shape or the anti-cone, whatever you want to call it. So let's apply that and come back to question 3. Now we're going to do one other thing different in this problem. And that is, we're going to change the axis. Instead of rotating around the x-axis, we want to now rotate around the y-axis. Rotate this way. So let's start by drawing. Step 1, reflect across the axis. But this time I'm reflecting across the y-axis. So I'm reflecting it this way. reflected across the y-axis, excuse me. And then 2, I need my skinny ovals perpendicular to the axis. So here's the axis that I am rotating around. That means I'm going to want skinny ovals right there, perpendicular. So any big lines that are perpendicular to the axis you're doing, that's where you do your skinny ovals. And to help visualize this, I can also do it up here too. So hopefully you're already starting to see that this is going to be a stadium shape. Because I'm taking that triangle and rotating it around, and now I can see my cylinder, but I don't want the cone. I just want everything else. So that's our stadium or our anti-cone. So this is stadium / anti-cone. And if we want to find the volume, we just learned at the start of this video that that is 2/3 pi r squared h. So once again, I need to find r and h. So r is half of the skinny oval. So I go to my skinny ovals, I want half of it. So that's going to be 4. Doesn't matter, it's negative, I just want the distance, so I'm just going to make it a positive. And height is perpendicular to the skinny oval. So that means here's my skinny oval, I want the height, so the height is this one, which looks to be 2. Don't go a little past 2, don't do 2.5, be careful about that. Our skinny oval makes it look like it's taller than it is. Look at the height of the triangle. So that height of that triangle is 2. So now I plug it in. The volume of the stadium is 2/3 pi 4 squared times h. 4 squared is 16 times 2 is 32 times 2 is 64. So I've got 64/3 pi for my volume. And once again, you can just take it at this step, type it all into your calculator, you'll get a decimal and just leave it at that. Okay, so we have now learned about cones, we have learned about stadiums or anti-cones, and we have done cylinders. In the next video, we're going to go backwards from what we've been doing. So instead of taking a 2D shape and rotating it to get a 3D shape, I'm going to take a 3D shape and go backwards to figure out what 2D shape would I rotate to get the 3D shape that I want. So that's what we're going to be doing in the next video.